let's go ahead and get started. So first things first, security orchestration and security automation. This is the first question. How, in your own words, would you define automation and orchestration? This is from the last class. So please answer in the thread, which, by the way, you all have been doing really well answering on the threads. So, all right. Now, remember, whenever I ask the question of in your own words, it's with the idea that you don't have to use technical jargon if you don't want to. You can use simplistic words or examples, like I used the one of an orchestra last time. Automation is singular, orchestration is plural. Yes, love it. Single and multiple. Okay, we picked up on that. It's a bunch of automation flows. It's just one flow. Yep. Automation without human orchestration organization. Brandon, I like that. Automation handles single security system, but orchestration deals with multiple. Automation and orchestration using, yep, all of these are hitting the nail on the head. Well done. Okay. That is absolutely accurate. Whenever you think of automation and orchestration, just remember that an automation is a part of orchestration because an orchestration is just a bunch of different automations. Okay. That being said, I did want to define automation a bit more. So it is true that automations are meant to reduce human intervention and make life a lot easier for the organization as a whole, right? So it's meant to handle anything that's repetitive, anything that's time consuming, anything that would be low priority, but that's still essential for the organization to operate. This is why a lot of automations are associated with things like log analysis, things like alerts, and the one that we talked about last class, patch management. So patch management is one of the best things that you can automate because it takes away so much time and effort and money for people needing to do things. With orchestration, the key word in orchestration is coordination. Orchestration is the coordination of a bunch of automated tasks. Now, like we talked about in last class, orchestration is really beneficial in the sense that you have to work with a bunch of different automations and non-automated servers and softwares and formats to make sure that they can all work together. The coordination piece is meant to make sure that they can different automations can work independent of each other or with each other. Now, just to go over class a little bit, right? We talked about some of the benefits of automation and orchestration. We said that it's really good to save time, money, efficiency. We also said that it's great for faster detection and response. And we also said that it's really good to reduce human error because when things are automated and where they're done by systems, well, then it reduces the possibility of human error. So all of those are benefits associated with automation and orchestration. This is important because today we're going to talk about some of the downsides of automation and orchestration. All right. So that's a quick wrap up. That was about, I don't know, about 7, 8 minutes of me reducing our entire 2-hour class from last week. But the key benefits, the key elements I want you to remember is automation, 1, orchestration, which all of you already got. And every single person answered in the thread. That is a win. Love it. Okay, so let's talk about enhancing cybersecurity. Now, as you can imagine, when it comes to cybersecurity, the name of the game is automation. Because when you're a cybersecurity professional, you want to spend your time and energy on the things that matter. You want to spend your time on things that are actually going to make a difference. So when it comes to security automation, well, then we're using technology, we're using IT systems to take away any repetitive tasks that we as cybersecurity professionals would have to do. So that makes it a lot better for us because efficiency. What do we mean by efficiency? It means that we don't need to do any more manual tasks. A good example is patch management. That may sound like an IT thing, but it's also a cybersecurity thing because it is required by a lot of compliance standards that you have a patch management system, meaning a patch management program that enables you to send out patches in a timely manner, right? Now, that's an example of that. Then we have scalability. So, excuse me, scalability is meaning when you have automated tasks that take away anything that needs to be repetitive, well, then you're able to scale your business a lot bigger. You can grow the volume. The idea here is building security in mind when you build out your network. So in such a way that, hey, we have a templated format for adding a server. Well, great, let's just add the server and then send out a package that automatically configures it, that type of thing. And then there's also strategic tasks such as making sure they can focus on critical issues and finally preventing burnout. Now, what we mean by burnout here, it is both a human perspective as well as a technological perspective. Sure, machines do not need to sleep, eat, or do the same things that humans do, but sometimes they can get overloaded. An example, if you have a pretty complex network and you have a lot of false positives, you'll get a lot of alerts. So if you have all of your alerts go to one system, well, then it could overload the system and burn it out. Same thing can be with a human. If, for example, if you look at your email, if you get so many emails from the same address, well, then that could be burnout as well. Now you turn those emails and those alerts to multiple different systems, well, then that's a lot for one or even a team of cybersecurity professionals to handle. So security automation kind of takes that burnout away. They automatically prioritize and find out which of these alerts are something we need to bring to the attention of human. Is it a minor alert, such as someone mistyping their password twice and then finally getting it the third time? Or is it like 5,000 attempted passwords in 2 seconds? Those are the type of prioritizations that security automation does. Now, what security orchestration does, on the other hand, is that it's really good for helping us with incidents. If you remember, we did a class on incident response, and I said how important it is to be timely, meaning time is money. If you don't respond to an incident in a timely fashion, well, then it could be catastrophic. It could expand. It could be more costly financially. So when you're able to get all the alerts in one place, well, then you bring down your MTR, your mean time to respond. Okay. And then integration with the different technologies, that's just the coordination of all the different automations and workflows, because keep in mind, when you're using automations, you're not just using the automations for automations in and of themselves. Those automations may require information from different databases, such as a CRM. Real-time visibility just means that you get to see in real time the health and status of all of your systems. I wanted to touch on this because I don't think I was too clear on it in last class. Now, what I meant by real-time visibility is if you have if you have a bunch of automations running that are specifically on monitoring, well, then all those automations will then be monitoring all of your systems. And let's say every second, they are checking the status, checking the health of each of the systems. As they're doing that, they're sending an alert that gives you a dashboard. And that dashboard shows you in real time all of the statuses, okay? So that's what I mean by real-time visibility, in case that wasn't clear. And then efficient threat hunting is just being able to focus on detection. So if you're wanting to find any threats on your network, well, then if you use orchestration, if you have about a bunch of automations that are looking for a specific signature or for a specific issue, it can be a lot faster for you to find any of those threats in your system, okay? Now, here's a real life example I want to use. Everyone is familiar with a firewall at this point, and a firewall in this case is a set of rules that essentially allow or deny traffic that comes in and out. Now, If you're inputting a new firewall, that new firewall could be misconfigured. As a reminder, a firewall has a set of rules and those rules have a sequence. So that means if one rule isn't satisfied, well, then they go to the next one, and then they go to the next one, and the next one, so on and so forth. So if one of those rules is misconfigured to be at the top, meaning let's say allow any is at the top, that means that the rest are going to be negated. That is called a misconfiguration of a firewall. So if that happens, when you have security automation and orchestration, it can look for and detect any of those misconfigurations and then correct it automatically with a script or to alert a security professional at a high priority saying, hey, we have a misconfiguration like this. Now, in this specific case, it's because if you want to include an automation and an orchestration, if there is a consistent issue of this coming up. A very common example is a company or an organization who uses legacy systems. Legacy systems tend to need to be set up a certain way initially, and then you have to go back and fix it later on. Some of those exist. I've seen it happen, but I wouldn't say it's super common, but that firewall is an example of how it can be beneficial to continue to monitor and detect it. All right. Now, we talked about the beauty of automation and orchestration. Well, then let's dig a little deeper into some of the challenges. Now, they are really beneficial. They save us a lot of time and everything, but something we need to understand is that automation and orchestration, well, let's talk about automation first. Automation can be pretty complex, right? Now, if you think about what makes an automation, let's say, for example, patch management. With patch management, you have a bunch of computers, let's say 1,000 computers. All those 1,000 computers, they all started at a different time. So they may have different operating systems. Well, you need to make sure that you know what operating system is on each computer. Then you need to know when the person last updated it. Then you also need to know if that person is still part of the organization or if they've been upgraded. You also need to know if they're using different systems on their computer that are maybe not upgraded, so on and so forth. So as you can tell, there are a lot of moving parts to patch management. So it can be complex to integrate all of these tools and platforms in order to work together correctly, because some of these platforms won't work well with other platforms. Sometimes you need a middle platform to communicate between the two. So it's a very big like puzzle game. So if you like puzzles, this might be a really good opportunity for you to figure out how the automations work. Another part is over reliance. Now, we talked about how beneficial it is, but I have seen some organizations really take it too far, where they become too dependent on automations to the point where it stops operations overall. What I mean by that is they're ignoring manual verification. They're ignoring security steps. What I mean by manual verification is something as simple as a reCAPTCHA or one of those sliding puzzle things, or they decide to automate the full detection process so that they don't need the security experts to validate if it's an actual issue or not. And it's very real. You get so comfortable with the automation that you don't automatically think too hard about the human element anymore. And we have to keep in mind the humanity of cybersecurity. Remember, we talked last class how you all were saying, is AI going to take over our jobs? No, because a human needs to make the decision. An AI can't decide on priority the same way a human does. I mentioned the movie iRobot. And this isn't a spoiler, but in the movie, there's a scene where a robot is meant to pick between two humans on who's going to survive an accident. And they picked based on probability. But in this case, one of the humans was a little younger, and the older human was like, save her, don't save me, save her. He was trying to be sacrificial. But the AI/robot picked the human because they had a higher live or survival capability. So that's an example of why humans are needed and why we need to keep the humanity. Now, another challenge is synchronizing automation with human monitoring. As you can imagine, if humans are going to have to validate any alerts that come in, well, then those decision makings need to coincide with humans that are present. For example, this is why we have a security operations center called a SOC, and this is why they're operational 24/7, because that means that someone can always make a decision based off the information that comes through. So that's why it's important to have a balance between automated procedures and human judgment. And then there's perceived adaptability. So this means that if you have automations, you may assume that they can adapt to all the other organizations' tools and platforms and different IT environments. Now, with those new adaptations, with those automations, can come some new risks. So you do have to make sure you validate those before enhancing it. And then there's reliability. Automations are still machines. Machines can still fail. So we're not saying that automations are the end all be all. We're saying that organizations cannot become too dependent on them because they could they could fail at whatever point. So you still need to have a fail safe for those. Regulatory compliance, that just means that if you are in a specific sector, well, then you may be required to not automate a specific process. You need to have a human do it. I do think that there are some of those in the automotive industry. That is slowly changing, though. Then there's the concept of false positives. So a false positive and a false negative is when an alert comes up that says, hey, we have an alert, but it's not a true alert. That's what a false positive is. A false negative is when they say, oh, no, this isn't an alert. But when you look into it, you're like, oh, this is fishy. This is a lot of login attempts. That is what we call a false negative. Now, both of these are still very possible. Just because they're machines doesn't mean they're perfect. So this is where humans come in and they can actually make some judgments after reviewing some things. Now, these are threats, and so you have to make sure that they are validated before you move forward with them. If any system, I got so many false positives, then how I can able to verify these statements? Maybe some of them need to verify by my own judgment and need more time to verify. That's a good question, Wajiha. So in this case, you're asking if I'm getting a lot of false positives, how exactly can I verify them? Well, there are two answers to that. The first one is the manual one. You get a human to verify each one. The second one is you have a automated verification. So this is another automation in and of itself who verifies the outputs of another automation. It's like a computer verifying a computer. Think of it as a double check. Now, there is a hybrid way that you could do both. You can have it partially verify and then have a human verify the outputs. That's one of the ways to do that. All right. Then there's the concept of protecting the automation tools themselves. As you can imagine, these automation tools have been given a command. The command is to do X, Y, Z. Now, if someone gets access to those automations, they can change those commands to be whatever they want. So you obviously have to make sure to protect those automations and those scripts from being exploitative or being manipulated, because attack could target them in order to compromise different industries and systems. All right. So let's talk about some of the complexities that come through here. Now, something to understand overall is that automations aren't a one size fits all. Automations need to be tailored. Organizations have to tailor them to their specific strategy. And so this involves really making sure that you're exploring things such as like the vulnerability of that automation. So let's say patch management, is that really important? Well, yeah, we don't want someone to send a potentially faulty system or faulty patch into the new computers. We want to make sure that's validated, right? So you want to make sure you protect the integrity of all these automations. You also want to consider the complexity of them. Now, when you're working with automations, when we're talking complexity, we're talking about, can these automations work asynchronously, or do they have dependencies? What are different things that would make this automation more complex? Can we simplify it? Or what are some things that could make it a bit more powerful, but not as complex, right? So you have to talk strategy with your team to find out how these automations can be either made better or made more simply. That being said, the complexity of the automation comes with what we call a cost. So if you're working on an automation, understand that an automation takes up bandwidth. It may take up internet time, electricity. It may take up cost to implement or cost to change or whatnot. Some of these automations are pretty complex, which we'll see later on. And so you want to analyze the complexity of those automations and see if any of the automations even need to exist. Maybe you can replace an automation with an actual software that does everything on the back end, so you don't need it anymore. Or maybe you have three automations that could just be combined into one. All of those are things related to cost that you want to keep in mind. Now, as the cybersecurity professionals, we care about the security of a system. That is very true. That being said, the organization that we work for, they care more about the bottom line and the output of what the organization gives. So it's our responsibility to try to minimize costs where possible while keeping our systems as secure as possible. It's a combination. Now, as you can imagine, there's the concept of single point of failure. So if your whole entire organizational ecosystem hinges on one specific automation, well, then that's what we call a single point of failure. An example, if any of you, let me pull this up, sales funnel. So this is an example of what we call a sales funnel, right? So the sales funnel consists of, here we go. So the sales funnel starts with, okay, they're aware of the brand, they're interested, they're considering it, they're intent on doing it, and then it eventually ends up in purchase, right? So this, every time I think of a single point of failure, I think of a funnel. Now, let's pretend this funnel is associated with sales, but instead the automation is hinging on automated emails being sent to all your potential customers. Now, I personally am not a fan of this, but it has been proven to get interesting leads. Okay. But if that automation fails and you have no other way to get customers, let's just say you're an SMB, a small medium business, right? And that's your only way to get leads. That's your single point of failure. If that automation of sending out those emails breaks, well, then that's what we be considered a single point of failure. So we need to make sure that you have multiple different avenues in order to do that, multiple different automations. So technical debt, what exactly is that? I will put it in very simple terms. Technical debt is similar to hoarding. That means that you have so much technology, so much software, so much stuff that it gets lost. A good way to understand technical debt is if, as of today, in your organization, 3 of your key IT or security personnel leave, well, then you need to ask yourself, okay, if a new person comes in, how easy is it for them to understand your ecosystem? If that ecosystem is like, oh, we don't know how this works because there's like 4 legacy systems or 4 legacy automations that work with there within it, okay? That is a problem because that means that it's not well documented. And I think by now you all know that I'm a huge fan of documenting everything as much as possible so that when someone new comes in, they're able to understand it a lot better, okay? So you want to reduce that by making sure that you are prioritizing, that you're doing your spring cleaning, prioritize different automations that need or not be there. And then the last one is sustained compatibility. Now, you don't, when you make an automation, it's very easy to say, okay, I made it, great, let it run forever, I'm gonna go focus on the other stuff. There is still a point of maintenance and there's still a point of sustaining those automations. So you need to make sure that they have your attention. You do look at them on a specific cadence. A lot of people request that you check on the automations on a quarterly basis to make sure they're functioning as they should, and change the automations if the company's strategy changes. So you need to make sure that you're supporting and maintaining these automations as best as possible. Now, these are the things to consider and keep in mind anytime you're working with automations, because yes, they're beautiful, they're wonderful, they do a lot. However, you need to keep in mind things such as cost, how complex they are, and whatnot. Let me go ahead and kind of give you all a real life example. So another automation that comes to mind is when a user gets locked out. So let's say they try their username and password 3 times, but they get it wrong. Once they get it wrong, well, then you lock them out of their account for security reasons, and then you tell them, hey, you have to reach out to IT, okay? Now, that's an example of one automation. Now, orchestration of this could be like changing and adapting the complexity of that automation into a full incident response. Meaning, okay, we have an automation for lockout. We're going to do another automation to verify the location of the device. And then we'll have another automation to find out the identity of the person. We'll also send out an email that says, hey, click this link. It's only valid for 10 minutes. That says you're trying to log in. Once you try to log in, there's an automation that goes through IAM process to see if you are who you say you are, and then we allow or disallow that. And so on and so forth until we get a full instant response. All of these things handle the complexity. Sure, you analyze the cost, but the benefit is that you have in real time able to respond if it is an incident. It takes away a single point of failure because it adds a multi-factor authentication. Technically, it would incur some technical debt, but you could have probably accomplished all this with your working stack. And then it pretty is compatible all the way around. All right. Now, showcasing success. What does that mean? Now, some examples are these examples are real life examples that I suggest all of you look up or at least aware of. So one of those is from Palo Alto Networks. If you're not familiar who they are, they do a lot of networking things. They're typically well known to be, they work in conjunction a lot of time with Cisco, even though they're completely two separate companies. They have something called a SOAR, which stands for Security, Orchestration, Automation, and Response. This is probably one of the biggest things you need to understand with security, orchestration, and automation is SOAR, SOAR, because SOAR is essentially a orchestration and automation, like a Powerball that's able to automate a bunch of repetitive tasks and essentially free up a lot of time. It also lets you do really good analysis and then boost your overall detection and response. So the XSOAR, Cortex SOAR, is essentially something that Palo Alto built to do exactly everything that we had talked about. Now, it is a sold product, and it is something that is very beneficial to a lot of organizations. I will say this, though, it is pretty complex to work with. So you need to be someone who is very security oriented and very technical in order to fully understand it. But that's an example of a successful orchestration and automation tool. IBM has been around for a really, really long time, and they have continued to become more and more powerful in the different realms of cybersecurity and IT. So what they built is they built a SIEM, right? So a SIEM is security incident and event management. It's essentially a location that streamlines the overall security and monitoring of an entire network. So QRadar is the name of their tool, and QRadar, it essentially works in compliance monitoring, compliance reporting. Now, what this does is this essentially kind of like scans your entire system based off different compliance reports or compliance needs that you have. And it is a bit customizable in the sense that you can pick which compliance standard you need to report on, and then you can see how well you fit to that standard, okay? Now, this is really good because you can be more compliant a lot easier. Typically, compliance requires a lot of manual checking and whatnot, and then you can identify the threats before they become too tangible, followed by what we talked about, alert fatigue before, okay? If you're unfamiliar, Rapid7 is a really good website that you all should be aware of because they do a lot of cybersecurity tools. They also sell some really cool gadgets. One of the things I think they still have it is you should be able to sign up for their marketing emails. So if you remember, I mentioned it's always good to sign up for marketing emails. That way you can keep in tabs on the newest things that are happening in cybersecurity, right? So Rapid7 is a really, really great tool. Yeah, so you can go ahead and check that out. But Rapid7 also has something called Insight Connect. So this does a lot of things. It does vulnerability management, incident response, and it does a lot of I would say coordination. So it's excuse me. It takes a lot of the security tools, put them together, and allow you to work off them. Okay. So I encourage you all to check them out. These are 3 examples of orchestration and automation that you can keep in mind. Now, what are some real world examples that we can actually talk about? Well, one of those is actually Huntress. So, you can how do I explain this without boring anyone? Now, Huntress is actually one of the best tools out there when it comes to endpoint detection and response. So endpoint security, as a reminder for everyone, is when you have a tool or software on your computer, on your end device, that actually protects your computer and detects if there's anything malicious on it. So Huntress does a lot of things. It can do a scan of your system in real time and then send it out to different people to validate. It has different automations that can stop some pretty complex attacks. And then it can overall do a lot to protect your system more than just an EDR system, right? Huntress is a really, really good tool that's known everywhere. A lot of mid-sized businesses use it a lot. And then HackerOne is a really great company as well. If you're unfamiliar with them, I highly suggest you follow them. They're all on LinkedIn. Some of them also have TikTok's accounts, but their main objective and their main point here is essentially offensive security. That means that they're more on the forefront. Okay. So they have a lot of offensive tools, but on the other hand, they have a lot of protective tools in order to make sure that you can protect yourself against any of the new attacks that come through. Now, a lot of these tools, such as Huntress and HackerOne, you will see that they have really big clients. A big example of this is General Motors, GM, and PayPal. These are big, huge companies that employ some of these guys in order to make sure that they are protecting themselves as best as possible. Another one is NowSecure. So, NowSecure is kind of like one of those systems that does pretty much a lot of security testing and incident response, but their main sector is actually on mobile apps. So this is anything on the App Store or the Google Store. They do a lot of the testing on these tools to make sure that they're not malicious and that they don't have any specific vulnerabilities. What happens more often than not is that if you're an app developer and you want to put something on Apple Store or up on the Google Store, they will go through their own version of application verification to make sure that it's not a Trojan horse. As a reminder, a Trojan horse parades itself as an actual app, but it's malicious. I'll give you all an example. So my mom, she uses an Android phone and she kept on getting ads, and the Android operating system was a little odd. So obviously she asked me to look into it when I saw her, and I realized that she had a Trojan horse on her phone, and she got it from a bootlegged website. She did not get it from the actual Google store. So this is an example of an application that was not vetted. Now, NowSecure does a lot of this vetting process for the mobile security applications. So keep that in mind. All right. Now, all of these companies that do a lot of these protection services and a lot of these protection tasks, it has a ripple effect. All right. What does that mean? Well, when you're protecting a lot of your data and a lot of your information, and when you're doing a lot of the testing, well, then you're building resilience. When you build resilience, well, then you're able to prioritize any of the things that are more important, specifically around scalability. All of these things are centered on making sure that the future of your company or the future of the operations are secure and that they aren't all relying on one single point of failure. Okay. So overall, when it comes to automations, it's really focused on boosting your incident response effectiveness and then securing your overall security posture and improving your operational efficiency, finally freeing up your team to focus on the tasks that matter. Those are four of the big reasons why automations are really needed. And if you're ever curious, you can go check out any of these three giants when it comes to automations. All right. Okay. Quiz time. Quiz thread. So we have two questions. Question number 1. Which of the following is a significant challenge associated with implementing security automation? Everyone is saying B. Okay. Yes, you all got that correctly. So, like I mentioned, the analysis of cost is something to keep in mind. An automation takes up time and it takes up bandwidth. So, we need to keep that in mind anytime we're working with automations in case it could be too expensive. There are some instances where organizations will say that automation is too expensive. Let's have our manual people do it. So, they hire entry-level workers in order to do that. It's very normal for interns to be hired to do like a lot of the manual log analysis type stuff. Question number 2, same thread. Managing the complexity of automated workflows is crucial. Which of the following is a recommended approach? Which of the following is a recommended approach? Everyone's answering on the thread. Looks like everyone is answering B again. That is correct. Now, when it comes, this is actually a really great life lesson too. When it comes to breaking down anything that's super complicated, that's super big, or any task that you have, then breaking it down into smaller and smaller chunks that is more manageable that you can do is a lot easier. If you all remember, I shared with you all the Eisenhower matrix, right? The Eisenhower matrix just takes your entire to-do list and cuts it down into 4 sections. And in those 4 sections, you're able to handle those tasks a lot better and prioritize, focus on the things that need to happen a lot better, okay? All right. We'll go ahead and give this a pause. So let's go. So now let's talk about some of the problems that come with automation. Now, as I mentioned, automation is complex, right? So you have to combine different tools. Not only do you have to combine different automation tools in and of themselves, right? So like if an automation does password lockout, then you need an IEM automation, then you need an automation to send out an email. All of these are different automations, right? However, they have to integrate with different systems. For example, APIs, data formats. They need to have access to maybe employee information, different names. So you need to make sure that all of these are able to work together cohesively. The cohesion requires you to have a proper design and proper implementation. That means you need to know what all of all your systems and automations can and cannot do. So it's important for everyone to keep that in mind. Oh, I also forgot to mention, congratulations to number 48. I don't know if anyone picked 48. I do see some of you all picking 48 after the timer goes out. I see that. It's a funny. I see that. Okay. Then there's workflow design and management. So when it comes to workflow design and management, that just means that in order to make sure that there's a really good orchestration, well, then you need to have a proper design. In this case, a lot of orchestrations are what we call in a design map. So that design map will show all the different systems, and then it'll show the process flow of what goes into a system, which goes into the automations, and that there you have to be able to pinpoint and find out where there might be any challenges. Challenges can be such as lag in the system, maybe too big of a bottleneck, maybe there needs to be a conversion of a date format or for whatever reason. There are a lot of different security procedures that come into play there. So you need to make sure that you design this from the start well and that you manage it properly. Managing it does not just mean design it, get it to work, done. You need to design it, maintain it, and find out if you need to change it for it to function properly. Now, that functioning properly piece, that's what I mean to adapting to changing risks. Now, as your orchestration workflows expand and as they continue to work with different formats and as technology changes, you're going to have to evolve them to be able to handle some of the new risks. For example, if there's an orchestration that has an automation that deals with Ivanti. So Ivanti is one of the CVEs that I had mentioned to you before. It is a VPN, and they had a CVE that put them at risk. So if that comes up, well, then you need to be able to adapt to that change pretty quickly, whether that be taking out the Ivanti automation and replacing it with something else, or you need to make that orchestration flexible enough to function without it or function with a replacement. And then operational silos. This just means if you have a bunch of different organizations that operate in their own specific funnel, well, then it might impede the ability of different automations or orchestrations to interwork together. So there needs to be a cohesive and solid understanding with the overall organization. So people need to understand why that automation exists or if it exists overall. With really big businesses, a lot of businesses don't know what tools and softwares exist in their system. So it's important from an awareness perspective to train all of your employees so that they understand that, hey, this specific automation exists and this is what that automation is meant to do. Now, this is essentially one of the gaps that come with automations, because when you have an organization that kind of exists in their own bubble, well, then they don't really talk to any other organizations, or they don't really want to use any of the software from other organizations. So you need to make sure that you do communication and that you work with those different organizations to let them know and make sure that they're aware of the ways that the different tools that they can use. And then we talked already about this before, maintain a balance between not over relying on automation, but making sure that human judgment is there as well. We want to make sure that things are efficient. So that's why orchestration and automation exist. But we also want to make sure that they're not operating completely independent of themselves, that there is a level of human interaction, or human, I should say, supervision, because it can be really difficult for these workflows to work well or incorporate human decisions if they don't allow for the space for humans to do that. This is why I say sometimes a lot of companies rely too much on automation, that they say, hey, our automations are great. We're using AI. It has a super high IQ, so it's really, really on point. But we also need to have those humans available there to validate it. Now, what are some overarching costs when it comes, what overarching challenges when it comes to automation? Well, the first one obviously is cost. What I mean by cost is you will have some licensing costs. You might have some initial implementation costs. You might have some unintended, unintended work that needs to happen on the actual automation in and of itself. So we need to balance all of the expenses along with any of the benefits that come with it. Then there's cultural resistance. Now, this is an HR thing, this is a company thing. Excuse me. So when I talk about cultural resistance, we're talking about adoption here. What I mean by adoption is if you introduce a new automation or a new way to do something to a company, well, then you might meet some cultural resistance, meaning that people say, hey, I liked doing it the manual way. It gives me more control, or I just like doing it the old way. Why do we have to change it? So you're going to have to work with the leadership team specifically to get their buy-in and say, hey, us as leaders, we believe in this, and this is going to help us down the long run. So you should believe in it too. It needs to come from a top-down approach because people tend to listen to higher leadership as opposed to lower, as opposed to like it coming from like the bottom up. Okay. And then enduring scalability. So when it comes to both of these systems, I'll answer that here in a second. When it comes to both these systems, right, you need to be able to grow with the enterprise. So one of the things that you may run into is implementing or kind of like adding a new system or a new design into your workflow to make it scalable overall. So these are a bunch of the different challenges that come with automations. Eric brought up a question. Judging from the ever improvement of automation and AL emergence as well as IA, what is the impact on cybersecurity careers outlook? It is good, Eric. Your job is not going to be impacted because there always needs to be human judgment. So anytime anyone asks you, hey, I heard AI is becoming a really big thing and it's replacing a lot of cybersecurity jobs, the first thing you can say is, yeah, but AI cannot replace human judgment. AI cannot fully take away our jobs because AI itself needs to be monitored. AI itself needs to be fed information. Humans feed that information to AI. Sure, is there talk of AI talking to AI and them kind of like learning from each other? Yeah, that's something that's becoming more of the norm, but overall your job is still secure. Okay? That's what some of the hiring managers that I've talked to have said. Now, should you know AI? Should you be familiar with AI and should you be able to understand it, be able to tell it what to do and what not to do, be able to validate it? Excuse me. Yes, that is very important to do. Very good question, Eric. All right, let's carry on. So this is a really great segue into the human oversight standpoint, right? Now, what we call this here is governance in automation. This is what all this is. Governance in automation means humans can still govern and take control when it comes to security. We do not want this to be like the situation where AI takes over everything. There are countless movies of how that's not a good idea. So humans need to maintain control. Well, how exactly can this be done? Well, again, automation is focused on automated repetitive tasks, right? So you want to leave the decision-making, big decision-making to the humans. That means, hey, do all this log analysis. Hey, do all this detection monitoring. Hey, do all this threat hunting. Oh, you found something? Great. You can't make a decision. When I'm talking about you, I'm saying the automation and AI can't make the decision. You have to let us do it. So you're just alerting us. You can give a recommendation, but we're going to make the final call in the end. Keep in mind, there are false positives and false negatives. So you have to make sure that you judge against that and you have someone verify if it's an actual threat or not, or if it's valid or not. So there's for that reason, we always want to make sure that humans have the last say. Humans are the people that at the end of the day say, yes, this is a good recommendation, or this is an actual finding, or no, this is not. This is really important because as technology gets better and better, there is going to be a shift, or maybe you've already seen there be a shift in technology trying to push us in one direction. Let me give you a very simple example. If any of you are on Instagram, TikTok, or YouTube, YouTube is very well known for doing this. Is if you have an account on YouTube, they'll present you with videos that they think you'll like. And then you can try it yourself. When you go on there and you refresh the page multiple times, the same videos will most likely pop up. That's because YouTube is using a backend automation to look at your profile, to look at your viewing history, and they say, hey, you should watch this. It no longer is a, hey, we think this is a good idea. You can click it if you want. Instead, they're trying to push you in that direction to watch a specific video. And this is very, very common. This is something that's happening with a bunch of social media sites, but YouTube is really big on this. And so that's why we need to say that there needs to be a human touch to all of this, because then it becomes too robotic. It becomes too controlling in the sense that even in cybersecurity, we're letting machines make decisions for humanity. And we as humans need to maintain that humanity and maintain that control. So, what exactly does that mean? That means that we as cybersecurity professionals, we need to know what automations exist on our network and in our system. And then we also need to understand how they work and what data they're using. The data piece is really important because data privacy is becoming such a huge thing that we need to understand every single system that is touching every single point of data in case we need to respond to a compliance request. Okay. So, how do we do that? Well, one of the best ways to do that is through continued audits and reviews, meaning that we're looking at all the automations, we're seeing how they work. Are we seeing any potential biases in them? Are we seeing any errors that are coming up often? Does that mean we need to change the automation? Does that mean that we need to maybe adjust the automation a little bit? Does that mean we need to put in a new automation entirely? Now, one thing everyone needs to understand is with the emergence of AI, there is going to be what we call bias. The bias means that AI is going to be very black and white in the sense that it says, okay, you have to do this or you can't do this. A very simple concept that should come to mind here is with automations growing in popularity in using AI, there's going to be a growing reliance on AI's decision or AI's suggestion. There is a very common theme in a lot of apocalyptic movies. And these apocalyptic movies say AI has imprisoned humanity because they said that humanity is destroying their own livelihood. In this case, they're talking about how humans are destroying the environment, how they're not taking care of the water systems, and how there's really the ozone layer is going away. And essentially, our world supply is really depleting, right? Now, this is a bias that AI has shown time and time again that means that if we give AI the rule of, hey, you need to protect humanity, then they say, okay, we need to protect you by imprisoning you. So that bias needs to be audited. That bias needs to be reviewed, and it needs to still have a kill switch that humans can make the final decision. Okay? All right. Now, a lot of you had questions about AI and how exactly we need to implement it. Well, there is a really huge surge right now in what we call ethical AI implementation. Ethical AI implementation in and of itself means that we are using what we call unbiased algorithms, unbiased data sets, and then trying to use AI in such a way that it's not going to cause human harm or cause damage or security risk to our network. Now, the idea here is that AI just takes data in and then makes decisions on it. So yes, it takes it at face value. However, there is a form of discrimination that AI has shown time and time again. You can look it up. So we need to make sure that we're not we're not using AI in a way that's unfair, but instead we're using these algorithms to inform our decisions. Now, these algorithms can be pretty complex in and of themselves, but as humans, we can go ahead and keep that in mind. Data privacy and security. So with automations, it's going to take some privacy. There is some sensitive information that can pass through them, so we still need to audit them, make sure that they are secure. And then there's something that we call explainable AI. So explainable AI, also known as XAI, is essentially thinking of transparency and fairness in AI and using algorithms that have like a guidebook to explain the reasoning behind a decision. This is really important when it comes to cybersecurity, because if an AI says, hey, we think this is a tangible threat, well, then you need to be able to say, why? Can you give us the explanation, right? And so explainable AI solutions can really do that. I would say the biggest thing to remember here is that humans need to be at the forefront of these automations, and it cannot be the entire AI and the entire machine who makes the decisions. That's who you come into security risk. Take this into consideration. Let's say, for example, that you say, okay, I want to automate my entire compliance program, meaning I want something to scan my systems, let me know what systems need to be updated, and then have it just do the updates. Well, then if an auditor comes in and say, hey, give me all of these audits, the days in which they happened, and the human verification. Well, then you're going to say, well, no human verified it. It was all done through AI. There are tools out there that I've seen that are going towards that route to make it completely automated, but it's not there yet. It's not there yet. All right. Quiz thread 2. So inside that thread, please let me know. A, B, C, or D. Security automation tools require ongoing maintenance. What does this include? All right, answers have come in. Everyone is saying B. That is correct. So automation tools require you to make sure that you're updating them to have security patches, just like you want to update all of your operating systems. Good job. Question number 2. A single point of failure in an automation workflow can disrupt security operations. How can this be avoided? A, B, C, or D? And everyone says B again. Great job, everyone. That's correct. So you want to make sure that you have workflows that have redundancies, failovers, and that there's not very many bottlenecks. Okay. Now, this is where we're going to be talking about the different scripting languages. Now, as a reminder, you can still be successful in cybersecurity if you don't know how to code. However, coding is an added benefit. So here we'll kind of break these down in a way that's a little easier to understand. The first thing that we need to understand is PowerShell. Now, PowerShell is specifically used in Windows environments, in Windows computers. Now, it's mainly used to configure different systems, to configure different networks. So think of it as a language or a scripting language that tells your Windows computer what specifically to do, okay? So it's mainly used a lot when we're talking about, now keep in mind, we're talking about automation, right? We're saying we want a computer to do something. All of these scripting tools are essentially the language used, that's why they call them scripting languages, to tell the computer or the system what to do. If you've ever wondered what is code, what is coding, what is programming, the concept of coding and programming is just speaking to a computer in a specific language that it understands to tell it to do something. That's what coding is, telling a computer to do something in a specific language. Obviously, there are different types of computers, so evidently there are different type of languages. With those different languages, they all have each and every one of them have their own strengths. So for example, with PowerShell, it's primarily used with Windows, and it can be used to essentially do a lot of things, such as it can automate a lot of repetitive tasks, such as permission management, permission checking, account management, and the most common way to use it is security configuration. So when you work in the labs, you'll work through some of these PowerShell options. Then it can also parse through a lot of log analysis. So it can take a bunch of logs and verify them, kind of like see if there's any suspicious activity. If it is required to, well, it can automate some very simple instant response steps. For example, PowerShell can be used to write a script on Windows computers. If they see that someone clicked a phishing email, well, then it can isolate that system. It can isolate it and block any specific malicious IPs from exiting that isolation location, or just block it in general. And then it can also do vulnerability scanning. So they have what we call command lines. Now, some of these commands can be used in multiple different places. And so you can talk that a little later. Here is an example. So this is automating disabling USB storage on all user machines. So this is a very common policy in a lot of computers. So if you're getting a company computer, they'll disable the ability for you to use the USB storage. So this is the command that you would put inside of PowerShell. So you would say, hey, get a local user for each object, set the user name, and say, hey, you're not allowed to use USB storage, okay? Now, I am just showing you this. You can learn more about this on your own. This would require a little extra, but I would say the biggest thing to remember with PowerShell is it's used for Windows. It's mainly used for security configuration and can do a lot of other security functionality. Now, one of the most common scripting languages that you will run into, or you'll hear people talk about, is Python. Python is one of the best tools that exists out there because it's actually the scripting language used to write automations. It's also really good at parsing through data. Parsing through data means that it's just reading through data, right? But the biggest thing that Python can be used for, I've seen in in real time, is actually penetration testing. So you can write your own scripts in Python to tell a specific system or tell a specific computer to do something, right? So that's one of the beauties of Python, is being able to write your own commands. Now, it is used a lot in what we call penetration testing, which is testing any of the security tool and any tool that you're allowed to quote unquote hack into. And it can do things like scan for vulnerabilities. It can do things like find any specific type of vulnerabilities that you really want to exploit, that kind of stuff. And it's all configurable because you can configure it with Python. And then there is a SIEM management. Reminder, SIEM stands for Security Information and Event Management. The entire idea here is to kind of configure the tool to give you a very specific response, as well, a very specific output, as well as a very specific response. It's also really good for threat gathering as well as tool development, okay? Now, I'm going to kind of like break this down in very simple formats, okay? So here, this is an example of a script that can download the latest vulnerability from public repository. Now, the idea here is that when you write a script, you can literally connect it to the internet and grab anything that's publicly available. So in this case, it says, all right, I'm going to make a request from this website, and then I'm going to use a GET request and say, hey, if the response status is this, I want to give out what we call a JSON payload. Now, a JSON payload, in very simple terms, is just a format that's easier for computers, that's easier for other systems to digest and ingest. Okay, that's all a JSON format is. Now, the reason why it wants to come out in a JSON format is because it's easier for you to download and then change it to different formats that's easier for humans to read. Okay, in this sense, this script is saying if you're unable to grab all of the vulnerabilities that exist out there, well, then I want you to say fail to download vulnerability list. That's just a very simple breakdown of a Python code. Okay, now one of the other scripting languages that you want to be aware of is called Bash. Now, Bash is mainly used for Linux systems, and same thing, it can do a lot of the same things that other tools can do. Now, this scripting language, if you're a tech guy or an IT guy, you should be familiar with it because it's really fun to use. I mainly use it when it comes to system administration because a lot of Linux systems can be used to set up Windows and other systems in of itself. Okay, so oh yeah, it's also used in Mac as well. So it's mainly used to do like user management, file permission changes, that kind of stuff. Okay, it's the language that you see a lot of Linux users use. And then there's log analysis, security scripting, and security frameworks. I'm going to buzz through a couple of these because we're running a bit low on time. So this one here is saying, hey, I want to find all of the logs for root. Root is being like the admin or the root cause, quote unquote, root cause that you want to log in from. So that you do a grep, which is kind of like a grab kind of thing, like find all of this information. Okay. Now there's if you're not familiar, I think I talked about this in the past, but there is a try hack me on Bash. So there's a room specifically for Bash scripting on try hack me that you can check out. This is not something that you have to do. I'm just sharing this information with you for your own personal reading or something you want to check out. Okay. All right. Let's carry on. Now there are other sorry, give me 1 second. There are other languages that also exist out there in that can be used for automation. So another one is Perl. So Perl is a very specific one. It's very, very unique, right? But its main use is essentially to query a really big library and is very text-based, right? So a lot of it is used to kind of like look through a lot of text information. So what you can use it for is you can use it to identify specific ports, you can analyze any specific activity, web security testing, you can write some Perl automations that will see if there are any web applications that are not performing well, if there are any basic vulnerabilities that they're having, or if there are any extracting any data, incident response, as well as SIEM. Now, something to understand is with SIEM, it's very, very powerful in the sense that it can integrate with a bunch of different languages. This is really good because if you have a developer who's really good at Python or Perl, they can configure the SIEM to give us the data that they really want, okay? Now, I'm not very familiar with Perl, and so I would say that you would want to look this up on your own, but this is essentially saying for it to scan a bunch of different ports, see which ones are open, and then give the results accordingly. Then we have Ruby. Now, there is something called Ruby as well as another one called Ruby on Rails. Now, this is what I like to call like a general scripting language. It's very like straightforward, it's easy to understand, and it's really meant to kind of like make scripting quote unquote easier in general. One of the benefits of Ruby and Ruby on Rails is that it has a huge, massive community gathering. For example, I don't know very many people who know Perl. I know a lot of people who know Python, and I know a lot of people who know a lot of Ruby, but I would say that Perl, I haven't run into like too often. Sure, I've met a couple people who know it, but the majority of the time I know people who do Ruby as well as Python. Now, as you can see, it's a common theme for all these scripting languages to be able to integrate with a seam. And this is important because these seams are really powerful because they are the quintessential orchestration and automation tool. That means that they're putting everything all together in one location so that you can read through them a lot easier, okay? With Ruby, it's really powerful because it's very simple to use and it leverages like things like the Metasploit framework to automate any penetration tasks. So an example with using Ruby is you can write an automation that looks through all of the Metasploit's web applications and the vulnerabilities that exist out there and say, hey, test out all of these. Right. That's why web applications is associated with Ruby, is because it's very like web application focused. Right. It can essentially point out all the vulnerabilities associated with web apps. So if you want to download specific files from like a web server, this is the format you would see. Now, if any of you are IT professionals, you may have run into this when you go into like the back end of a specific website, because a lot of these websites tend to use Ruby to run a lot of their scripts. Believe it or not, all of these automations that we're talking about, right? I know we're talking about security automations, but websites have automations in and of themselves that function behind the web application. And so sometimes they use all these different scripting languages to run these automations. Now, there should have been a clicking moment there because you should have realized, oh, websites have automations. So they probably have an automation that says, if I'm browsing on a specific product, well, there's an automation that will pop up another product based on what I'm looking at. You know, these are the type of scripts that can live on different websites. All right. Now let's talk about, excuse me, talk about some scripting examples. Now, I think I'm going to go ahead and skip this because I think it's a lot better if you all do this actively with in the lab, because you are going to, I do believe you have a lab on scripting. So I don't want to spend too much time on this, and I want to run through the Kahoot. Let me see here. Okay. Let me see how we can do this. Okay, so this is what I will do. So I will go through these from at a high level, because I want you all to actually do this in real time. And I think that you'll have other people that'll be better fit to do it. Okay. Now, if I were to kind of like explain this, right? When it comes to scripting in general, right? Well, then there are several steps that you need to take. For example, you're going to do some scripting with PowerShell, and then you're going to work with Task Scheduler a little bit, right? So in this scenario, okay, we want to do a security log collection, right? If you already have a virtual machine, you can use that. If you have a Windows computer, you can use that. But I highly encourage you to not use your personal computer because you might mess some things up. These scripts can be a little hard to reverse. So in essence, you want to open up a code text base, right? So you can use PowerShell or Visual Studio Code. These are both two different options that are really good for anyone who's just starting out. And then you want to set up your script. Now, here's one of the benefits. When you're working with scripts, there are so many examples online. So many examples online. With the emergence of AI, well, then this has kind of become really easy. For example, if you all are not familiar, there is this AI called Claude. And Claude is really well known to be even better than ChatGPT when it comes to code creation. Okay. So you can really work with Claude to get any of these scripting done. Okay. So you can set up your script. It's as easy as copying and pasting from AI. You say, hey, I want you to write me a script that essentially gives me all of the log locations in this specific format. You can copy that. And then you will go ahead and kind of like give it a definition. So you would write the script itself, and then you would need to save it and run it. Now, if you've never run into scripts before, if you've never done it before, well, then one of the things I would encourage you to I would like to frame in your mind is that a script is like um, writing a command or writing a list of things that you want a computer to do. You write it in a text document, you save it in a specific format, and then you do what we call you run the program or you run the script. That means you can either double click it and it runs the script, or you can go to PowerShell and say, hey, I want you to reference this script and I want you to run it. That's more often what typically happens. And you'll run through that in all of this. Is there a VM to do this on a Mac? Brendan, that's a really good question. I think that the one that I've used, let me double check for you real quick, is you can use any like VM that's out there. Which one was the one I used? I think I used VirtualBox. Yeah. It was VirtualBox. So VirtualBox works really well, mainly because they're working with Oracle. It's very easy to set up. All you have to do is download an ISO, and it works. It works pretty easily. You'll be able to watch some tutorials that will be able to help you in that. If your start menu location is different or screen size, you can configure all of that, like a Formula X says. Yeah. Now, when you're working with scripts, right? If you're working with data exfiltration, or you want to pull out data, something that you'll need to do is you need to specify like an input directory. So this typically requires you to include a file path of where a specific file is located so that it can look at it, whether you're wanting to do like a password review or a server review. You'll need to kind of give it a location. And this is pretty much for anything that's related to files, okay? And you can have it do analyze the logs, then you save, test, run the script, and that, so on and so forth. Now, in this case, you can actually work with Task Scheduler to kind of like, if you have multiple scripts or AKA multiple automations, well, then you can use Task Scheduler as an orchestration tool to coordinate which of these actions to take first. That's what I would suggest you take from this, okay? Again, I don't want to spend too long on this. We're also going to, oh no, these are good questions to go do. Okay. Quiz thread. Stick with me, y'all. I think we'll be able to end a little early here if I play my cards right. So, question number 1. What is the primary concern regarding technical debt in security automation? Technical debt. And then we have the answer that came in. Everyone is saying that. Everyone is saying D. The cost to maintain automation tools outweigh the initial investment. That is correct. That's why you need to clean house. Second question. Testing and validating automation scripts are crucial before deployment. Why? A, B, C, or D? Everyone's saying it's B. Okay, let's pause and let's talk about this for a second. Now, remember when we talked about security or security by design and how I kept saying developers need to audit their code to make sure that it doesn't just accomplish the goal of the code, but it does so securely? This is a really big reason why. Now, keep in mind, when you're writing scripts, technically you're coding because these automations, if they're written in Ruby, Perl, Python, what have you, they're all built by humans. Humans are building this, okay? So there's a human error element in it. If your script it has any sort of error in it, or if it presents any sort of vulnerability, such as it says, hey, I want you to pull all the logs from this website and I want you to store it in this FTP file that is unencrypted and plain text, that's not good because then that data could potentially be vulnerable to exfiltration. So that's an example of a security vulnerability that could happen if your security code is not properly tested and properly validated. What will most likely happen in a lot of organizations is they'll essentially take a piece of code and run it in what we call a QA environment, which stands for quality assurance. This is typically done by a human so that they can test and say, all right, run that. Is it working? Is it downloading everything we need? Is it not? What in the code do we need to change? So on and so forth. Okay. So that's something to understand about code validation. Okay. Now, how exactly can we put this into practice? Well, I'll kind of break it down for you. When it comes to automation and orchestration, the first thing is finding out what can we automate first. Let's say you're a very small business and you're a small business and you're trying to become more secure, you're trying to save more time, you're trying to save costs and make sure your security team is able to focus on the big things. Well, one of the first things you can do when it comes to automation or orchestration is you can identify repetitive tasks. What exactly does that mean? That means that you have all your to-dos that you have to do on a daily basis that every employee has to do or every department has to do, and then you essentially highlight what are these tasks that we can take away? What are tasks that can be replaced with AI? Now, this means that you just want to replace the things that are essential to the business, but that aren't exactly moving the needle. Instead, they're taking up time where the employees could be spending on more priority level tasks. Okay. So things such as patch management, log monitoring, as well as vulnerability scans, these are all automated tasks that can be done by automation. Okay. Then what you do is you kind of build what we call a prototype. So the prototype is where you essentially build out a small version of your automation, and then you test it out in a QA environment. So an example is a vulnerability scan. Typically, a lot of organizations, they'll have a mirrored production environment, which means everything that's in production is in QA, except less heavy duty, less data, less processing, taking up less space, right? But there, they can deploy the prototype of their vulnerability scan automation and say, hey, we're going to make this vulnerability in these 3 spots. Let's deploy this script and this automation to see if it catches that vulnerability. When you do that prototype, well, then you're able to find out if it works properly. Then typically you do a phase 2, 3, where you make it a little bigger, a little bit more complex. Once you're sure that it works really well, that's when you do a full implementation. Now, this is where you'll probably be involving a project manager to do an implementation plan, to have it done in phases, to make sure it's done securely and that it's not going to impact a lot of real things that are in production. And then you use what we call modular design. Modular design just means that whatever design or implementation you do can scale. That means that you can adjust it, you can change it, you can expand it, you can make it smaller. The essential idea is that when you decide to make changes, it's not going to take a full re-implementation. It just takes a little bit of adjustments here and there. So let's say you started out small and you integrated automation. Great. Well, then the next thing you need to do is you need to do continuous evaluation. That means that you are going to continue assessing the effectiveness of the automation. You will be implementing monitoring and logging on all of your automations, meaning that you understand the health of each one. Because keep in mind, each of these automations are essentially a task, or even think of it as an asset, such as an employee doing a specific thing. So you want to make sure that they're as healthy as possible. Then you want to do regular reviews and audits, like we had talked about before, as well as what we call feedback loops. So what exactly is a feedback loop? It's essentially where you look at the performance of the automation, and then you see if there are any adjustments that have to be done. And then you go through a circular process of saying, okay, let's review this automation. Is it going well? Are there any changes we need to make? No? Okay, great. Let's go ahead and review it again. And it's just a loop that kind of like goes round and round with the idea to improve the automation's performance. That could include changing the automation entirely. If it comes to a point where the strategy of the business needs to adjust, well, then that's definitely something we need to keep in mind. All right. So let's say you have you've tested it, you've identified the task, you built the prototype, you've implemented it, and it's in a modular design that can be adjusted bit by bit. Well, then next thing you want to do is you want to implement, and you've already judged its effectiveness and you've established a regular auditing period. Well, the next thing to do is you want to invest in team skill development. What exactly does that mean? Well, that means that you essentially really want to make sure that you are giving your employees and team members time to learn the automation tool, learn the data set it uses, as well as learn the new automation tools that exist. This is why a lot of companies, they provide like learning resources for employees to get better at scripting and coding, because then they can make better automations, right? So that's why when you go to a really good company, they'll say, hey, here's access to Udemy, here's access to Coursera. And then if you do both, well, then you can do it for free. So these are all examples of ways to do continuous learning. Cross-functional training is really important because not only do you want your team members that are working with the automation, know what the automation is, but they also need to understand the different team members that are involved in that. That means that if you're an IT team, well, then you want to work with the legal team to know the implications if your script has vulnerabilities that could cause the business like millions of dollars. And then professional development, that's akin to continuous learning. That just means that a good organization will invest in your professional growth so that you can continue to learn how to make things better for the organization. Okay, then comes collaboration and encouraging teamwork. So automations, like I said, they work with a lot of different departments. They use a lot of different systems, different servers. So you want to make sure that you have a group, or at least a core team that works on the different automations that involve different team members. So this means that each team member has a say in how that automation operates and how it functions, if there are changes that need to be made. Typically, the automation tool will have a supporting team, and that supporting team also does the auditing, the reviews. They decide if the automation is still needs to exist, if it needs to change, all of the above, okay? And then there are typically what we call wikis. Now, in a lot of tech companies, there is a repository of how all the different automation works, or how all different tools work. Now, this is really cool because the wiki is something that is public for the entire company, and they can learn about the automation. This is really good because it focuses around the thing I truly love that you all are already familiar with, which is documentation. Documentation is really great because then you know what happened when, and you can essentially pick it up. So making sure to share on a wiki page is really, really common to avoid specific challenges. And then the last one is inclusive planning process. So this means that you essentially are involving different stakeholders from different departments. An example is legal will typically involved in like big decisions when it comes to like deploying the script or like what script you're building. Security and data privacy, as well as marketing, if it's a marketing tool. All of these different departments will probably be involved in the planning process, especially if they're going to be touching any piece of their data. All right. Overall, okay, before we go to the conclusion, I did want to touch on this. So if you are interested in learning more, I highly encourage you to check out the Stuxnet case study. Now, if you're unfamiliar with Stuxnet, it was a really sophisticated malware that was going after Iranian nuclear facilities, right? So I won't go into the specific details of this, but if you want to dig more into it, you can. It's really interesting how it happened. It was done through like a USB drive, right? And so it spread silently, and it did a lot of damage because it impacted a lot of what we call PLCs. PLCs are programmable logic controllers. This means that they are controllers that can kind of like influence the action of other computers, right? So there are a lot of lessons to be learned here, but I will let you all kind of like look into all of these on your own. But Stuxnet is definitely a something you should know. All right. We have a question. I start work soon, so I need to leave now. Thanks, Dave, for the lesson. You're very welcome, Alfie, and thanks for staying as much as you could. Okay. And then I see Jignesh. What would you ask? You're asking, is Intel Management Engine a concern? Depends. I would say depends who you ask, right? Because now, yes, it is a concern because it uses a separate processor, I think, for CPUs, and it acts very independent of the operating system. So if that gets compromised, well, then that could be a really huge risk because it essentially can include, I think it is like remote management. It can include some remote management. I would have to dig into it more, but I did see an article on this recently. Good question, Jignesh. I would say yes, but depends who you talk to. Okay. In conclusion, automation and orchestration. Automation, one. Orchestration, many. The way to create these automations and orchestrations is through telling the computer to take a specific action based on using a language that they understand. That's what the scripting languages are, okay? So what are some things you need to consider when it comes to the challenges of automations? Well, there could be some integration challenges, meaning that they may not work seamlessly with other tools, so you have to make sure that they are compatible. Then there's security versus speed. Do you want to automate everything so that your team can focus on the important stuff? Or do you want it to be very secure and make sure that humans are having a lot more of a say in the modern security infrastructure of your organization. Then there's making sure your automation and orchestrations are going to be able to be modular, meaning that they can be tweaked slightly to include any of the new threats that come up and be able to scale. Finally, there's ethical and privacy concerns. So anytime you're building out these automations, you want to make sure that they're in accordance with any compliance standards that you have, that you're using AI ethically, and that you're keeping data privacy in mind. Again, the last point is in regards to security by design. So if you are doing cybersecurity properly, well, then you're not just building a tool, you're building a tool securely. So keep that in mind.